Hi Passionate Scientists, my name is Jorge and today we're going to do an integral. Concretely, we are going to do a secant. But first of all, I want to point out the difference between a secant has an odd power and the other one, or the other kind of secant, the one that has an even power. So let's talk about first the secant with an even power, for example, squared. Yeah? This is really, when you have a secant with an even power, it's quite simple, as you just have to compute or plug in the substitution. Obviously we know that secant is 1 divided by cosine, so right here we have cosine squared dx, and this is just, as all we know, the tangent. So it's really direct, it's straightforward and straightforward integral. So now you see that the even power doesn't present difficulty, but it's true that with the odd power you'll have difficulty doing it, but not because it's difficult at all. It's because it's lengthy, and you'll see it right now. So we're going to do, for example, secant to the third power. Okay? Now, we're doing the same. We're starting it at the same point, for example, or as this, 1 dx. At this point we cannot. We're not interested in doing this operation, or split this integral in 1 divided cosine x and multiplied 1 divided cosine squared x. That doesn't help. So we're going to do another thing. Multiply up and down by cosine x to have the following integral. Okay, so now we know that we have an even power and an odd power. So we know that when we have an odd power, we have to compute the following substitution, the following substitution: t cosine of x. Okay, so we just have to derive and compute. Okay, so now integral of dt. Well, and as all we know, cosine x is equal to square root of 1 minus sin sine squared x, and to the fourth power, just to the fourth power. So now I'm gonna do this quick because I think it's quite easy to say. So now we have 1 minus t squared. Alright, we have it. So now, if you see, we have a better looking integral than the original one. So the substitution paid off. So we're doing good. Now we're gonna factorize this, and I'm gonna do it slowly because it seems quite straightforward, but just in case. Okay, so now we're doing it as follows. We have t fourth to t squared plus 1. I'm gonna do the following change just to make it easy. T squared equals to u, okay? So now we have u squared minus 2u plus 1. And we're factorizing this again. So now u, okay. So now we have the following. minus 1, minus 1. As this is equal to, yes, and this can be factorized as follows. I'm doing all the process to make it clear, okay? So now we have it as follows. T, I'm doing this first. This is the same, so it will be like, it will be everything done when I did this one. So now T is minus 1, so plus 1 minus 1 here. So that means that this factorized equals to integral dt t plus 1 squared t minus 1 squared. So now we have it. We have it, everything. We have the denominator factorized. Now we just have to, we have a rational one, a rational integral, so we have to do the sweet table method. Let's do it. Squared. Once we are at this point, it's quite easy, okay? We have AT plus B, t plus 1 squared, plus CT plus D, t minus 1 squared. Here is a square. Okay, we have it. So now we have AT plus B, t minus 1 squared, plus CT plus D. You know, here is just algebra, simple algebra, but we just have to be careful here because it's easy, but we can fail at any point. So take care at this moment or at this part of the integral. Now, we just have to compute values for t, for example, for example 1, to make this disappear, and we have the following for, well, let's do it quickly or quicker. C plus D. Okay, we all agree. Yes. And T. Yes, correct. And now T equal minus 1. Okay, sorry. Fine. We have minus A plus B fourth. This is the second equation. Now we are doing, for example, 0, just to disappear. So it will be like B plus D equal to 1. Yes. And now, just to end, for example, let's compute 2. Okay, so it will be like 18 A plus let's do it. Sorry. Wait a second. C. Okay. 18C. Yes. And 9D plus 2A plus B equal to 1. Okay, we got it. Now we have 4 equations and 4 we have 4 equations and 4 variables. Okay, now we can solve this. For example, let's do it. Let's solve for C. I'm gonna do, well, here we can apply, this is just solving equations. So we are doing the following. We have C plus D equal 1/4, B plus d. Let's, for example, yeah, multiply this for minus 1, d minus 1. We eliminate the d, and we have minus 3/4. Okay, and alright, and now let's compute this one, this new equation, in the second one, just to eliminate b. So we have this 2, and we have minus a, sorry, b 1/4, and c minus b minus 3/4. Fine. So now this is goodbye, and plus c, and we have minus 4 is minus 2. Then we have c, which equals yeah, wait a second. This is correct. So let's solve for a. 1/2 plus c. Yes. So we have it right here. 1/2 is correct. Let's check it out. Yes. Yes. Fine. We have a. So we have 18z plus 9. Let's solve for d. Let's solve for d right here. For example, in the second. Yeah, let's solve here for c. Like d equal to 1/4 minus c. Yeah, so we have 9. 1/4 minus c. Yeah, and now for a. Yes, we have it here. It'll be like a. It's 1 plus c. This is multiplied by 2. Okay, multiplied by 2. And now b. B, we have it here. We have it right here. So we just have to compute. Three-fourths minus c equal to 1. So now we just have to solve for c. 18c plus 9/4 minus 9c plus 1 plus 2c plus 3/4. Yeah, let's check it out. Right here. Minus c. Alright. So we have it. And now it will be like 9c here there's a mistake. I realized b is minus b, so ma plus minus plus. Fine. So here's plus c. Yes. So this is just a little bit messy, but quite straightforward. Now 9c, 12c. Yes. And right here we have 9/4, 12/4, that's 4. Yeah, we can remove this. Nine, 4, 3, a 3, okay, if I'm not mistaken. Just, yes, I think it's a 3, a minus 3. So now we have c equals to 3 c equals to minus 3, or yes, 3, 3, 3, 1/4, minus 1/4, yes. Okay, so now we'll have everything. A equals to the following: 4 minus 1, no? Plus 1, sorry. Yes. And AC, now let's look for B. B will be like B equal to C, okay, so it's 1/2, yes. And we have A, we have B, we have C, just D left. Just have to compute for D. So D, where's D? D. D is here. It's a little bit messy. So 1/4, C, one half, yes. Okay, so now we have the values, and we have to solve the integrals that are as follows. We have AT plus B, so t plus 1 squared. A, we know it's 1/4, and B, so A is 1/4, and B is equal, let's check it out, 1, 2, okay, so 1, 2, yes, that means that obviously well, in this case it would be like 1t plus B. B that we know is 1/2. So I'm going slowly. Okay, fine. And the other one, that will be like t minus 1 squared, and we do the same. We know that c equals to minus 1/4, and d equals to 1/2. So it's the same, but with a negative here. 1/4. Yes, fine. We're almost done. So now, because if you realize we have t plus 1 and t plus 2, so if we achieve right here in the upper part of the fraction at t plus 1, we could simplify this integral. So now, let's do it. We can do the following: 1/4 t plus 1 squared dt, sorry, differential, poor differential. So now we have 1/4 1 t plus 1 squared, yes, and we have plus 1 t here, and t plus, yes, minus t plus 1, t minus 1 squared, and the following. Yes, we have it. The differential right here. Okay, okay. We're going good. We're doing good. Now we know that this can be simplified. Yes? And here we can do the following. We can do +1, -1, minus, okay? And we can simplify now this one. So now we can directly solve this integral, and the fourth are directly solving integrals. We can solve the four of them directly. So let's do it. Let's shed some light on it. Now it will be like 1/4 logarithm t plus 1 and -1/4 logarithm t minus 1. Yes? We got it? Yes. And we just have 2 left. Fine. So that it will be like -1/4 t plus 1 and the same. Yes? Yes. So this is. So we just have to compute. We have to. We can combine this logarithm rules, as all we know, sine x, you know t was equal to sine of x, so now +1 sine of x minus 1, yes, and we got it. And what could we do here? Let's simplify it a little bit. Okay, -1/4 t plus 1 is sine x plus 1 sine, okay, wait a second, here has to be a mistake, right here, it's a minus here, okay, yes, -1, and we got it, we almost got it, fantastic, we have 1 here. So we have here sine squared of x minus 1. What's this? Cosine minus cosine of x. Yes, plus 1. So this one just disappears, and this negative can be put right here outside, and we have 1/4 cosine of squared of x, and sorry, we have it here, okay, and let's solve in the upper part of the fraction. That will be sine of x minus 1 sine of x plus 1. Goodbye 1, and this is 2, that can be, it's in now, so we have 1/2 of the cosine squared of x sine of x. Fine. So and 1/4 logarithm of sine of x plus 1 sine of x minus 1. So this is the final answer. Beautiful, yes. So I hope see you next time, and it was a pleasure. Let's keep working. Goodbye.